Assalamu alaikum, dear students. Welcome to your mathematics class. This is your mathematics teacher Said Mansoor Sadat, and we will have class 11th mathematics. Hope everybody is fine at their homes and safe from this deadly coronavirus these days. Before starting your lessons or touching anything, your laptop, your tablets, or anything else related to your studies, your book, your pencil, your notebook, try to clean your hands, try to wash your hands before starting today's lesson. Now in class 11th, we will start our lesson with conic sections, and the second conic section that we will study this year, which is ellipse. The first conic section was circle that you have studied in class 10. Now let's start with the conic sections. At first, let's look at these shapes. All of them are cones, or two cones, vertex to vertex, located with each other. Now there's a plane, the purple color plane, which transmitted, or we can say that, which are traveling along with different angles. As you can see, the circle parallel to the base of the cone, and oblique with that. Just cut. I've cut it one side. Cut one side from both of the cones. These are conic sections: the circle, ellipse, parabola, and hyperbola. Now they are not shown with cones every time. You've studied circle. What was circle? Circle, section of a right circular cone by a plane parallel to its base. Plane, this purple color plane, is taking a section from what? From a cone, and this plane should be parallel to base of cone. So the picture which is going to be derived is of a circle. The other one is ellipse, section of a right circular cone by an oblique plane. The oblique plane, or a plane with some gradient, forms what? Forms the ellipse. Now these are the definitions of circle, ellipse, parabola, or hyperbola according to conic sections. In geometry or in mathematics, they have different definitions which we will study. The third one is parabola, section of a right circular cone by a horizontal plane. Yes, the horizontal plane, or we can say that if we take a parabola, a cone, and cut it horizontally, the section which is formed is a shape like this one, and it's called parabola. Hyperbola, section of two right circular cones by a horizontal plane. Two right circular cones when have a section by what? By a horizontal plane. Gives you the form or the shape hyperbola. Now let's move on to our first lesson, which is ellipse. At first, we will define ellipse. The definition of ellipse is such that ellipse is a geometrical shape in which sum of distances from a point on circumference to foci is equal to length of major diameter. Ellipse is a geometrical shape in which sum of distances from a point on circumference to foci. Foci means to focus. We have focus number 1 and focus number 2. Both of them are called foci, is equal to length of major diameter. There are some terms that we should study about. At first, let's look at this definition. We have a coordinate plane with x and y axes. Now, this is an ellipse, and according to definition, we have two focus, which we say foci, and a point on circumference. Now it says that sum of distances from a point on circumference to foci. We have one point on circumference and we have two focus, which is now foci. Now the distance from the first one plus the distance from the second one is equal to the length of major diameter from A to A bar. Major diameter. What is the major diameter? Yes, major diameter or major axis, the distance between A and A bar. The distance between the point A to the point A bar as the major axis. Minor axis, the distance between B and B bar. This one is the minor. The longest distance from circumference to circumference, from one side of circumference to other side of circumferences, major axis or major diameter. And the smallest distance or the shortest distance is also known as minor axis or minor diameter. Okay, now according to this definition, we can say that an ellipse, when we add the distances mf and mf bar, it should be equal to the distance from A up to A bar, as it's written now here. mf plus mf bar is equal to AA bar. Now these mf and mf bar, these two show distances, therefore we have taken the absolute value from them, because sometimes if it's calculated and the value is negative or minus, so from the absolute value we will have only the distance, and it means that we will have the positive value of that. Now, as we said that we had foci, we had major and minor axis or diameters and other terms related to ellipse. Now we will start with them. Let's have some patience. The very first one is vertices. We have four vertex or four vertices any ellipse. The first one is A bar, B, and B bar. A bar, B, and B bar. These four are what? Yeah, the vertices of ellipse. Now, this point is the origin, and you can see that with A I have written some coordinates, which A and 0. It means that on x-axis the value of A is, or the distance it covered is A. It does not cover any kind of distance on y-axis, or we can say that it does not have any depth or height. So on y-axis it's 0. The same distance that's traveled towards point A is traveled towards point A bar also, which is taken minus A because of the direction. Yeah. The other one we have foci. The points F and F bar are foci. One of them is called focus, as we say, F and F bar. There is some relation between them, between the vertices and the foci, which can be calculated using the formula C equal to both plus and minus square root of A square minus B square. A is the distance from center to vertex A, and B is the distance from origin 0 up to vertex B. Now, as we said that we have two diameters here in ellipse, which is major diameter and minor diameter. The longest and shortest distances between two sides in an ellipse is known as diameter. We have A bar, the longest, which is known as major diameter, and B bar, which is the shortest, and we know that as minor diameter. The relation between diameters, foci and vertices is C equal to square root of A square minus B square. And the very last but not the least, which is eccentricity, we cannot see anything here named eccentricity. We cannot see anything here named eccentricity, and we can say that it's not present in the shape, but it determines the shape of ellipse, that if the ellipse is lengthy one or a short one. The value of eccentricity is between 0 and 1. If it's 1, so it's a circle. If it's 0, then it is a hyperbola. But now it is between 0 and 1, and anytime you want to calculate the value of eccentricity for an ellipse, so it should be between 0 and 1, and the formula to calculate it is E equal to C by A. The formula used to calculate eccentricity for ellipse is E equal to C by A. Thank you very much, dear students. This was all for today, and you have to memorize the definitions. You have to memorize the definition of terms related to ellipse. It was all for today. If you have any kind of questions, you can contact us through the WhatsApp of Mathematics Class 11. Till next lecture, have a nice day. Allah Hafiz.